In this video, we will introduce sine and cosine. We've been doing some work with triangles in recent lessons, and we've mentioned that we were going to go over some computations using right triangles specifically. Today we are introducing sine and cosine, which are two of our basic trigonometry functions, often shortened to trig functions. Tangent is the third main function that typically gets introduced alongside these two, but we have created a separate lesson for it. We are going to focus on building your intuition on what these functions are before we actually go into how we calculate them. Let's say we have this triangle, and for the purposes of this section, we only care about the fact that it's a right triangle. The measurements of the other angles don't matter. We have this angle here called theta, and if you've never seen a theta before, it's just a variable, just like x, y, or z, or a, b, or c. Labeling the other parts of this triangle, we have our hypotenuse, which we introduced in an earlier video. And then we've labeled this leg the opposite because it is opposite or across from our angle. And we have this leg labeled adjacent because it is adjacent or next to our angle. Now let's say you're standing at our angle theta. For the purposes of this example, we'll just say that you've gotten a new bow and you're going out to practice before your first day on the archery team. So for the purposes of this lesson, we will assume that the arrow travels in a straight line. Taking the triangle out of it for a second, if you were to shoot your arrow directly out in front of you, it would travel the farthest distance possible outwards, but the least possible distance upwards. If you were to shoot the arrow directly up into the air, you would have the exact opposite situation. Your arrow would travel the highest it possibly could, but it wouldn't move outwards at all. Let's represent this using percentages. In our first scenario, when we shot the arrow directly outwards, we traveled 100% of the possible distance outwards, but 0% of the possible distance upwards. In the second scenario, we traveled 0% of the possible distance out, but 100% of the possible distance up. Anything in between these two angles will give us varying percentages in these two directions. And this is how we should think of sine and cosine. Let's relate this back to our triangle. We made an angle of 0 degrees with our bow to move as far as we could outwards. We made an angle of 90 degrees with our bow to move as far as we could upwards. Depending on the angle we make with our bow, our arrow will travel different distances in both directions, and those distances are different percentages of what's possible. If we wanted to travel, say 3 feet out and 4 feet up, what angle would we have to hold our bow? If we hold our bow at an angle of 37 degrees, how far did the arrow travel? This is where those trig functions come in. If you recall from your previous schooling, a percentage is just a fraction or ratio. Finding the sine and cosine of an angle is just finding the ratio that represents the distances we have described. The hypotenuse of our triangle represents how far your arrow has traveled. The leg labeled opposite represents the height that the arrow reached, and the leg labeled adjacent represents the distance outwards the arrow went. Since we have two measurements or percentages we are concerned with, we have two different calculations to make. Say we take our height and divide this by the distance our arrow traveled in the direction that it was shot. The resulting ratio, which we can convert into a percentage, tells us how much of its potential height our arrow reached. We call this calculation the sine. So based on how we labeled this triangle, this calculation is just opposite over hypotenuse. And with trig functions, we don't typically want to write out the full word every time, as some of their names get pretty long. So we would represent sine using sin, and then in parentheses, we would put the representation of our angle. So in this case, we would use theta. Now say we take the distance the arrow traveled outwards and divide that by the distance it traveled in the direction it was shot again. This ratio or percentage tells us how much of the potential outward reach our arrow traveled. We call this calculation the cosine, which we write as cos. In parentheses, we have our angle, and we find this using adjacent divided by our hypotenuse. You may have made the observation that as our angle increases, our potential height or sine increases, and our potential distance out or cosine decreases. This creates an arc, which we will discuss further in a future video. Now let's do some calculations. Find the sine and cosine of angle A and angle B. So we're working with two different angles, and we'll start with angle A. So if we wanted to find the sine of this angle, we need the side that is opposite and the hypotenuse. So the sine of angle A is 4 divided by 5. If we wanted the cosine of angle A, we need the side that is adjacent and the hypotenuse again. So the cosine of angle A is 3 divided by 5. If we wanted to find the sine of angle B, we would take the side that is opposite and our hypotenuse again. So sine of angle B is equal to 3 divided by 5. And then to find the cosine, we would take the side that is adjacent to angle B and then the hypotenuse again. So we have the cosine of angle B is equal to 4 divided by 5. It's that simple. These are very straightforward calculations. We use sine and cosine in so many areas of mathematics. Relating to content that you are most likely learning around the same time you are being introduced to these functions, some things you can do include solving for the missing angles and sides of a triangle, using things like the law of cosines and the law of sines. But in terms of real-world application, these functions are used for things like GPS systems you have on your cell phone, anything having to do with the transmission of sound waves and signals like with radio broadcasting, and so much more. If you thought this lesson was helpful, make sure you like the video so we know you'd like to see more like this, and subscribe to stay up to date on our latest content.